Okay, so let's break down this 2023 question 10 part C. And this is pretty brutal, especially when you consider that it might take 20 minutes for us here to explain and it's only worth 5 marks. And if you had, done pretty much anything in the right direction, you could expect to get, let's say, 2, 3, 4 of those marks. So we're going to break it down and do a good exploration of it for the understanding, in the hope that if something like this came up again. But I do think that this is something that would be very difficult to get in the time constraints in the exam, unless you were very good at pattern recognition and you kind of spotted the pattern for this, which I'm not even sure that I would do. Like I said, the end of the exam, question 10, you're nearly finished, you've been at it 2.5 hours, like whether you'd spot this or not. I think this is extremely difficult, but let's give it a go. What are they asking us? They're asking us for, and we'll put it up here, they're asking us for the area of the sum of the triangles in the nth pattern. So the nth pattern is called Tn. This is T1. It has one rectangle. T2 has 2 rectangles. T3 has 3 rectangles. T4 has 4 rectangles. T5 has 5 rectangles. Tn would have n rectangles. So n is just a general term. So we want a formula that I can just plug in a number for n, and I can figure out what's the sum of the areas of the rectangles in that pattern. So the first thing we're going to do is let's try and figure out what's going down and sort of reverse engineer this. Bring it back to what are the areas of these 4 triangles, and then let's see, can we go and bring n into it. N being 1 in this one, 2 in this one, 3 in this one, n is equal to 4 in this one, and then n is going to be equal to n in the one that we're looking at. We're going to have an n in our formula. So we've already done in the B part, we've figured out how we can work out the bases of these other triangles. The heights are pretty easy. Let's put in the heights of the ones that we have. So the height of the first triangle is given to us, in which case the height of the rectangle is the same, which is 8. The height of the triangle is always 8. It's consistent throughout this question. So each of these 2 rectangles are going to be 4 each. In this one, the height is 8, and we already found out that these are 8 over 3 each. And what we can see pretty quickly, and I think it's worth writing down on the side, is that the height of the rectangles in a particular pattern, let's put it over here, the height is equal to 8, it's always 8, over the number of, let's put down n, for the number of rectangles we have. So it's 8 over n is the height of each rectangle, and we'll come back to that in a few minutes. Okay, so the last one we didn't do, so the last one is 8 over the number of rectangles, which is 4, so each of these is 2. In terms of the bases, the first one is easy, the base of that rectangle is 2. The widths of each of these rectangles in term 2, well, this is 2, that's again consistent throughout the question. The bases of the bottom rectangle is always 2. And the top triangle, let's do similar triangles. We'll just do it over here on the side, we'll call this x. So in this big triangle, we have a base of 2 and a height of 8. So let's say 8 over 2. So 8 over 2 is equal to, in the little triangle, the height is 4, and the width or base is x. So 8x equals 8x equals 1. So let's replace this with a 1. So this is 1. Okay, and we'll try and see if there's a pattern then that we can work out in terms of n for these widths, but we'll just do a little bit more work first. So the third one then, obviously this is also 2. Let's call the top little triangle the base of that x, and let's work out, well, we already worked this out, sorry, in the B part we already have this work done, so there's no point reinventing the wheel. The base of the second, or the middle rectangle, was 4 over 3, and the top one was 2 over 3. Okay, and then in this one over here, we have the base of the bottom rectangle is 2, and clearly, there is an issue in the scale of these diagrams. These diagrams are horrendous. The base here is 2 and the height is 2. That's clearly a diagram that's incorrect. But I think for them to actually have drawn it, you would have really tall triangles like this. But for some reason they didn't feel it was necessary to do that. Okay, so let's work out the base of each of these. So this is x, this triangle up here, let's have a base of x. The height of the big triangle is 8, the base of the big triangle is 2, and that's the same proportion as the small triangle on top, which has a height of 2 and a base of x. 8x equals 4, so 8 by x is equal to 4, and x equals a half. So this up here is a half. Similarly with this triangle here, let's work out this one. Let's call this y. So the big triangle is height of 8, the base is 2, and then the triangle made up of the top two rectangles has a height of 4 over y 8, y equals 8, y equals 1. And we can probably see the pattern that's coming here, but we'll just do the last one anyway. So then this last triangle, we have 8 over 2 equals the height here of this triangle is 6 over, let's call this z. So 8z equals 12, and z is equal to 1.5, or let's call it 3 over 2. Now, what we kind of want for our formulas, and let's rub out these triangles, but we'll leave in what we found out. What we have here is half, we have 1, and we have 3 over 2. So we'll rub out this. So this is just using similar triangles to work out the heights. And again, that was in the C. This is the C part. In the B part, we had done that for working out the area of these three triangles. Rectangles. We worked out the area of these three rectangles was 32 over 3. Okay, so let's start by just writing down the sum of the areas of the rectangles in each of these patterns to see can we just identify some kind of a pattern in the question. So the first one here, the area, the sum of the areas, we'll call it the area in, let's say, pattern 1, where there's one rectangle, is the base multiplied by the height. 2 by 8 is 16. Okay, come over to the second one. The area of these two triangles is the sum of the two areas of the triangle. So let's take the top triangle, which is a base of 1 multiplied by a height of 4, plus the bottom rectangles, a base of 2 by a height of 4. So that's going to be 4 plus 8, which is 12. So it seems like the sum of the areas of the rectangles is something that's decreasing. As you add in more rectangles, the areas of the sum of those rectangles decreases. It goes from 16 to 12. It'll be interesting to see now, is the areas linear? If it was, it'll be very easy to find a formula, but we'll see that it's not. In the third one, we've already the work done, but we'll still write out the pattern. We know that it's 32 over 3 from the previous part, but the area of the three triangles is, again, going from the top, we have the base 2 over 3 times the height, which is 8 over 3, plus in the middle rectangle, we have the base 4 over 3 times the height, which is 8 over 3, plus then the bottom triangle, we have a base of 2 times the height, which is 8 over 3. And we already know that this is 32 over 3, 32 over 3 is 10 and 2/3. So it's not linear. This one dropped by an area of 4, and this is only dropped by an area of 1 1/3. So this isn't a linear sequence. The areas don't form a linear sequence. But interestingly, we will actually be using linear or arithmetic sequences in some way to do this question. Okay, then let's go to the fourth one. So A4 is equal to, going from the top again, we have the base half by 2, then we have 1 by 2 plus 3 over 2 by 2, and then finally we have 2 by 2. And let's move this away for a second. We'll put that up there. Okay, so what's that? That is going to be 1 plus 2 plus 6. Oh, 1 plus 2 plus, no, 3. 3 over 2 times 2 is 3, plus 2 by 2 is 4, and that's 6 and 4 is 10. So it only goes down by another little bit. So the gap, or the amount that it's decreasing by, seems to be getting smaller. So we went from 16 to 12 to 10 and 2/3. The area of 4 triangles is 10. Now, so this is what we're doing, but how do we do it for pattern N, which we don't know how many triangles it is, or rectangles it is. We won't be able to find a specific answer, but we can find an answer in terms of n. So let's take these formulas and see what's happening in terms of n. So what I'm going to do first is, in the first one here, let's write the height first. The height is 8, and let's multiply that by 2. Plus, in the second one, we can see the height is consistent in both terms, like it's a common factor. We're going to take it out, 4, and we're going to multiply that by 1 plus 2. So 4 into 1 by 4 is 1, and 4 into 2 by 4 is 2. Then let's go to the third pattern, and we're going to take out the height. The height is 8 over 3. And then we have bases of 2/3 plus 4/3 plus, now 2 here, we could write that as 6/3. Just because we want to establish a pattern, we can see 2/3 plus 4/3 plus 6/3. And it's probably this middle pattern that is going to establish for us most clearly a formula in n. And that's why maybe this question could have been done in a small amount of time on the exam. Like if people had just focused on what's happening with this pattern, the third one, and could I make a formula just based on what I see there, could I then find an n formula? And you probably could, but we're trying to break down and have understanding as to why it works. Okay, and then let's look at the fourth one, and we'll take out the height. The height is 2, and that's going to be on a half plus 1 plus 3 over 2 plus 2. Okay, is anything coming out more clearly? Well, maybe still not really, and we want to break it down a little bit further. Well, let's look at it like this. We already established that the height was always going to be, the height of the rectangles was going to be 8, the total height of the triangle, divided by the number of pieces you're breaking it down into. So for the third one, it's pretty clear, and it's easy. It's 8 over 3, that's 8 over n, the pattern number. Well, what about the second one here, A2? Well, 4 is 8 over 2. The pattern number is 2. So this is 8 over 2 on 1 plus 2. And then over here, we have that this is A1 is 8 over 1 times 2. And then let's go over to the fourth one, which is 2 is the height, 8 over the pattern number 4. 2 is 8 over 4. Okay, so that's where we're at now. So we've modified this, so we know that in our formula, and let's fill in the second one as well, 4 over 3 plus 6 over 3. So we know that in our formula up here, we have an 8 over n at the start. So it's the height of the triangle divided by whatever pattern you're on. Okay, now let's try and establish some kind of pattern for what's inside the bracket here. So we can see in our one here that this is 2 over 3 plus 4 over 3 plus 6. Well, if you go over, and if we decide that the bottom number is of the fraction is the term number, so that's fine in this third one because that was the way it was written in the B part. And again, maybe they wanted us just to focus on this one and come up with the pattern. But let's apply that to the other ones. So in the first one, A1, that's 8 over 1 times the pattern number is 1, so 2 is 2 over 1. What you're doing is you're making the bottom of the fraction the pattern number because it seems to be in pattern 3 that that's what happens. And then A2, well, that's 8 over 2. And then if the bottom of the fraction is going to be 2, the pattern number, well, 1 is 2 over 2 and 2 is 4 over 2. Okay, so we can kind of see what's happening here. So we have 8 over 2 on 2 over 2 plus 4 over 2, and then we've 8 over 3 on 2 over 3 plus 4 over 3 plus 6 over 3. I can nearly guess what's going to happen over here. This is going to be 8 over 4. Let's make the bottom of these fractions over 4, and I could nearly fill them in based on what's happening here. This is 2 plus 4 plus 6. This is going to be a half. If we multiply the top by 2 is 2. 1 is 4 over 4. 3 over 2 is the same as 6 over 4. And 2 is 8 over 4. So hopefully we can see what's happening. Now again, I'm not saying that people would have necessarily seen this in the exam. I think it's very difficult to extrapolate this. Maybe people could extrapolate it just from the formula you had worked with previously. That was probably the idea. but we're just showing that it works for every formula. So what is happening then? Well, for the nth one, it's going to be, let's put a bracket, the fraction is going to be n. Okay, we can see that the fraction is going to be n. Now we don't know how many there is, so let's leave a gap and then plus a few more at the end. I'm just running out of space here. So let's bring this down here. Or do you know what we'll do? We'll minimize it a bit. Okay, so we're just giving ourselves a bit of room. So what I'm saying is that it seems to be that the height of each rectangle is outside of a bracket, and then inside the bracket we start at 2 and put it over the pattern number. Then it seems to be we go to 4 and put it over the pattern number. Then it seems to be we do 6 over the pattern number, then it would be plus 8 over the pattern number, then plus 10 and so on. Now what would the last few terms be? Well, let's have a think about this. What would the last few terms be? This lad is getting in our way. We don't need him anymore. Let's get rid of him. Okay, so let's have a look. So in pattern 1, pattern 1 might be the best one to look at because there's only one piece. Let's look at pattern 2. So in pattern 2, we finished with 4 over 2. And then in pattern 3, we finished with 6 over 3. And then in pattern 4, we finished with 8 over 4. So what is that last number seeming to be? Well, what's the relationship between 6 and the pattern number 3? And what's the relationship between 8 and the pattern number 4? And what's the relationship between 4 and the pattern number 2? And 2 and the pattern number 1? Well, it seems to be you finish on twice the pattern number. So we're going to go as far as 2n over n. Now, folks, that's the answer. This is the answer to the question. The area is 8 over n on 2 over n plus 4 over n plus 6 over n plus all the way up to 2n over n. The problem with this pattern is, like if I said to you, find the answer for n equals 20, like we haven't got these middle terms to be able to put in, and so we have to tidy this up a little further. Okay, let's take it and write it down here and see how we can finish off this question. So this is the answer up here. If you want to find out the sum of the areas in n triangles, which is Tn, the Tn pattern, it's 8 over n on 2 over n plus 4 over n plus 6 over n, all the way up to twice whatever the pattern number is. So let's see how we can work with this. So let's write it down here. So our answer is an equals 8 over n on 2 over n plus 4 over n plus 6 over n plus ... all the way up to 2n over n. Well, the first thing I can see to do here is there's an n on the bottom of all of these. So let's take that outside. That n on the bottom, let's bring that outside and make this an n squared. And then we're left within the bracket 2 plus 4 plus 6 plus ... plus all the way up to 2n. Okay, well now this is beginning to be a bit more clear. To find the area, we're going to do 8 over the pattern number squared on the sum of this sequence. Now this is an arithmetic sequence. The gaps are the same. The difference between these terms is 2. Now our areas weren't 16, 12, 10 and 2/3, 10. They didn't make a linear sequence, but there is a linear sequence within this. Now it's multiplied by 8 over n squared. That's why it's clearly not a linear sequence in itself, but the bracket part is. So what I'm going to do is I'm going to take the bracket part, the formula for the sum to n terms, and let's write it in a different color. The sum to n terms of a linear sequence is n over 2 on 2a plus n minus 1 times d. So let's sub in Sn is equal to n, the pattern number, divided by 2, on 2 by the first term, which is 2, plus n minus 1 by the difference, which is 2. Tidy this up and we get n over 2 on 4 plus 2n minus 2. Tidy it up further, we get n over 2 on 4 minus 2 is 2, so this is 2n plus 2. And then what we'll do is let us divide this 2 into these 2's, so we have n on n plus 1. So we can replace all of this in the bracket with n on n plus 1. Here we have an n inside the bracket above in the numerator, let's say, and we have an n squared in the denominator, so we can cancel one of those and say that this is 8 over n on n plus 1. And you could, look, you could tidy it up, you could multiply it out. Let's multiply it out. You could say that it's 8n plus 8 over n. That's our formula. Now, just to show you that it works, let's sub in a couple of numbers into it. Let's find the area to one term. Well, that's going to be 8 times 1 plus 8 over n, which is 1. So that's 8 and 8 is 16 over 1, which is 16. And it was 16 earlier, we saw that. Let's try it for A2, so 2 rectangles. So it would be 8 by 2 plus 8 over 2. That's 16 plus 8 is 24, divided by 2 is 12. And we did see it was 12. Let's try it for 3. So that's 8 by 3 plus 8 over 3, which is equal to 8 by 3 is 24 plus 8 is 32 over 3. And we knew that it was that. And then the last one, just to show it fully works, it's 8 by 4 plus 8 over 4. 8 by 4 is 32 plus 8 is 40 over 4 is 10. And they were the numbers we got. And the beauty of it is we have a formula now. an equals 8 n plus 8 over n, that if you wanted to find out in a sequence way into the future, not maybe too far, but let's say the 10th, if you were to break your initial triangle here, that was 2 by 8i, if you were to break it into 10 rectangles, and I'm not going to do that, but you can imagine what they would look like, into 10 of them, the 10 of those rectangles would be, the areas of them would be 8 by 10 plus 8 over 10, which is 88 over 10, which would be 8.8, which is smaller than, you know, that we've seen the pattern is reducing down, and by the time you get to 10 rectangles, it's 8.8. So look, it was worth 5 marks. All of that work for 5 marks. Maybe there's a way easier way to see it, but that's the breakdown. Like, the easier way, just to come back to it, is maybe people would have seen that in the third sequence, which was the answer to the B part of the question, that it was the height multiplied by the sum of the bases. The sum of the bases was 2 over 3 plus 4 over 3 plus 6 over 3. And maybe people would have seen that this is the third pattern, and maybe they'd seen, well, for the nth pattern, then clearly it's 8 over n on 2 over n plus 4 over n plus 6 over n plus ... and then as far as twice whatever it is, so 2n over n. Now maybe people would have seen that without all of this exploration and whatever, but that's the question. Look, I think it's very difficult. Hope it gives a little bit of clarity, and if something like that came up again, you know, it's about you just finding a formula and sort of, like I said earlier, reverse engineering how you would get those different areas with proper numbers, and reverse engineering it to see, well, what would I do if that number each time was n and not 1 or 2 or 3 or 4. Okay,